Hi everyone, I'm going to be talking about the ovarian cycle today. To start, I'm going to start with a brief overview. So before you hit puberty, your oogonia are undergoing excessive mitosis, as you can see right here, and they're producing primordial follicles. But once you hit puberty, you start to produce primary follicles instead of the primordial follicles, which then, with stimulation from FSH, gets converted into secondary follicles, and again with FSH, get converted into Graafian follicles following that as well. So like I said, these changes are due to hormones being released from the anterior pituitary gland, gonadotropin releasing hormone, GnRH. Once you hit puberty, this your nucleus starts releasing the GnRH, which stimulates the anterior pituitary gland to release FSH as well as LH. And FSH is follicle stimulating hormone, and this is what causes these changes in these follicles to create our Graafian follicle, which is our mature or dominant follicle, in other words. And then once our Graafian follicle is made, after an LH surge and after we moved into the luteum phase, our Graafian follicle gets converted into our corpus luteum, which produces progesterone, which is used to prepare the uterus for pregnancy. And that's kind of a brief overview of the ovarian cycle, but let's get into the phases now and more of the specifics. So the first phase of the ovarian cycle is the follicular phase. In this phase, you're starting with about 10 to 20 primary follicles, as we can see here, and excuse me, these get converted into 5 to 7 dominant follicles, or the Graafian follicles like we saw above. And this stage in this phase mostly occurs due to the impact of FSH. So during the first 8 to 10 days, FSH stimulates the granulosa and the thecal cells, as can be seen here, to secrete estrogen into the lumen of the follicle. FSH induces the proliferation of granulosa cells in the developing follicles and the expression of luteinizing hormone receptors on these granulosa cells. As the production of estrogen increases into the lumen of the follicle, FSH is inhibited by the pituitary gland in this negative feedback loop. So we see an increase in estrogen in the lumen of the cells because of FSH, but once we have an increase, FSH actually is inhibited. So it's this negative feedback loop that we see that's happening in these granulosa and thecal cells. The accumulation of estrogens in the lumen of the dominant follicle makes the follicle grow and develop independently of FSH, and the FSH in the circulation inhibits further production of FSH. 2 or 3 days before LH levels begin to increase, 1 or occasionally 2 of the recruited follicles emerges as dominant, and this increase in estrogen that we were just talking about in the dominant follicle indirectly lowers the levels of LH and FSH, which leads to death of the other follicles while the dominant follicle emerges. So our dominant follicle will emerge, and those that were not the dominant follicles will actually form the new layer of the endometrial of the uterus. So just in the late follicular stage, just before the ovulation, there's a huge LH surge, which in turn is what is going to stimulate this ovulation. So after this LH surge, we have our mature follicle here, which releases a secondary oocyte, which gets embedded into the infundibulum of the uterine tube. And that's our ovulation step of our cycle. So we have then the luteal phase. The luteal phase takes the remaining parts of the mature follicle and converts it into the corpus callosum, which in turn produces progesterone. And this occurs with the help of LH as well as a little bit of FSH as well. And those are the 3 phases of the ovarian cycle. Now I'm going to talk a little bit more specifically about the hormone breakdown within these phases. So generally, we have FSH that comes in, and it's going to act on our follicle to create our dominant follicle. Our dominant follicle produces estradiol. And when we have high estradiol, this is when our LH surge occurs. And this, like we said, in turn is going to cause ovulation to occur as well. After ovulation, we go into the luteal phase, which has the corpus luteum, and this with LH comes in, stimulates the corpus luteum, which stimulates the release of estradiol and progesterone. So LH comes in and is going to stimulate these two hormones in the corpus luteum of the luteal phase of the ovarian cycle. And then now to talk about a little bit about the breakdown specifically in these phases. In the early part of the follicular phase, we have an increase in FSH, a decrease in LH, a decrease in estradiol, a decrease in progesterone, a decrease in inhibin A, and then an increase in inhibin B. So that's in the early part. And then about 7 to 10 days in of the follicular phase, so about halfway through the follicular phase, we have a gonadotropin surge. And this, we also have estradiol that increases and inhibin A increases as well. And then LH will increase slightly or it'll remain about the same. But it might be increasing slightly, building up to that big LH surge that we see, and our FSH goes down here. And the last part of the follicular phase, we have this LH surge, which, like we said, is going to cause this ovulation. And during the ovulation phase, estradiol goes back down and inhibin B also goes back down. And then finally, in the luteal phase, we have an increase in progesterone and estradiol. Like we said, our corpus luteum is releasing those hormones. So these both increase in the luteal phase. The progesterone produced by the corpus luteum transforms the proliferative endometrial into a secretory one in anticipation of the implantation of a fertilized oocyte. In the absence of pregnancy, the corpus luteum has about a 14 to 16-day lifespan, following which the production of progesterone and other luteal hormones ceases, menstruation commences, and then another ovarian cycle would start fresh. But in the event of fertilization and successful fertilization and implantation, the lifespan of the corpus luteum and its resultant production of progesterone are prolonged until the placenta develops the capacity to produce sufficient amounts of progesterone on its own to the fetus. So that's kind of generally a brief overview of the ovarian cycle and kind of the hormone breakdown that we see in each phase. And yeah, I hope this was helpful.